Hello, I'm here at World Hydrogen Week in Copenhagen. I'm here with Ermanno Filippi from Casale. Thank you so much. He is the Chief Technology Officer. We really appreciate you being here with us today. Just to set the scene, can you tell us a little bit about what your company does and how it fits into the hydrogen value chain?
Sure. Thank you, Ella. Casale is a licensor of many technologies. So we develop technologies for the production of several molecules like ammonia, methanol, and also downstream like urea, melamine, nitric acid, nitrates, phosphate, hydrogen as well. And therefore, in the view of the energy transition, a lot of these molecules are like, of course, ammonia, methanol, and hydrogen are considered as energy vector. But there are also chemicals that are already used to make fertilizer. Ammonia is the main carrier for nitrogen that is converted into urea, nitric acid, and so on to make fertilizer. And methanol is used for chemicals, is an intermediate. And so all this enter into the intention to decarbonize the chemical industry, the energy industry, and all these molecules can have a very specific role in this view. And Casale does not only develop the technologies and license the technology, but we are also acting as a contractor. So we also build the plant based on our technology to produce these products, let's say, like nitrates, fertilizer, and so on.
Thank you so much. On the topic of nitrates fertilizers, I understand you're heavily involved in the new green fertilizer plant in Paraguay. Can you tell us a little bit about that?
Sure. That is an extremely important project for Casale, but I would say as a whole for the world, because it's the first green fertilizer plant that is being built. And it is really a combination of very positive factors that allowed this project to go ahead. Atome is a project developer, and they found a place in Paraguay where there is a lot of renewable power coming from an hydro project that is available at a very low price. And that is the fundamental ingredient to make green fertilizer at affordable prices. And then we have, since the very beginning, Atome to develop this project, defining the plant configuration, what could be the best product that should be considered. And then we went all through the various steps of feasibility study, engineering, and so on. We completed the FEED at the end of last year, and then early this year we got the contract for the supply on EPC basis of the full plant. So Casale is supplying all the technologies except the hydrogen production and air separation unit, but all the downstream ammonia, nitric acid, nitrates, and granulation for for CIN are supplied by Casale. And we supply not only the technology, but we also build the plant.
Thank you. So as an early adopter, there must be a lot of learnings that you can share with us. Can you tell us a couple that come to the top of your mind?
Yes. No, that is very true, because let's say, okay, during the development of the project, we have considered different configuration. At the beginning, the project was born as a pure ammonia producer, but then the client immediately, after a short while, understood that there was not a real market. It was very difficult to find an off-taker, so they switched to fertilizer, and we, of course, together we defined that the fertilizer would be a CIN because it's very suitable for the market locally. It is also relatively easy to be produced. And so, let's say, there were an evolution in the terms of what the plant should have been about the production. And then when we started engineering, of course, being both the licensor of the technology and the engineering designer, we could find a lot of, let's say, integration, the type of layout, a lot of things that were necessary to bring the cost of the project down to an acceptable level. And that, this being the first green fertilizer plant, also for us was a kind of a first, in this type of detailed engineering activity. So really we did really a lot of work, but the results we are now very happy. Yes.
Yeah, and ultimately it does all boil down to cost. Now, I just want to take a second to recognize we're talking a lot about your green fertilizer plant that you've contributed to heavily, but you also have FlexiBlue products as well. Can you tell us a little bit about those?
Yes, that's right. So there are, this is, let's say, the other phase of the energy transition where fossil fuel are still used to produce chemicals, but the carbon, the CO2 emissions are captured and sequestrated. So we developed a process to produce what is called blue ammonia and also blue hydrogen. And we named this FlexiBlue because we give a lot of flexibility in terms of the size that can be achieved from the plant and other factors. And this is essentially a process based on our autothermal reforming technology for ammonia. While for hydrogen, we collaborated with Technip to develop a process that we call ROX, that is based on the combination of our autothermal reforming and Technip parallel reforming that is called TPR. So we have both this solution, and we can reach very, very large capacity, both in terms of hydrogen or ammonia, at a very competitive price.
Yeah, so what I'm hearing is that both green and blue have a very important place to play in the decarbonisation roadmap. But just going back to green ammonia for a second, green ammonia is considered a great vector for hydrogen, so as a hydrogen carrier. But one of the big considerations here is that it needs to be cracked. Can you tell us a little bit about what goes into this process? Is there any considerations that we need to think about when it comes to emissions or energy losses?
Yeah, sure. That is a very good point. Yes, Casale has developed also his own ammonia cracking process, and that is based on two concepts. First, as you mentioned, about the energy efficiency, so to have a very high efficiency of conversion of ammonia into hydrogen, so that not too much energy is lost there, and that is a very important point. Second, to have a very reliable design because, let's say, the plant is operating in conditions that are pretty severe in terms of presence of chemicals like ammonia and hydrogen that are attacking the metallurgy, and the temperature is also very high, so the choice of the metallurgy, the configuration of the reactors and so on is very important. And then, of course, you mentioned emission. This is also a very important factor. And here, of course, Casale has a lot of experience in terms of NOx emission. That is what can actually happen. Because being owner of the nitric acid technology, we also own the technology to abate the NOx emission and N2O emission from nitric acid. So we own not only the configuration of the reactor and so on, but the actual catalysts that are used. So we could, let's say, incorporate this know-how about emission also in the design of this ammonia cracking technology.
And am I right in thinking that abatement technology can be retrofitted into existing plants as well?
Yes, absolutely. This is a very good point because especially N2O emission are very important for climate change because the equivalent factor is very high, and N2O emission are actually relatively simple not to abate because it's a matter of having a proper reactor and a proper catalyst, and then you convert N2O into nitrogen and water. No? So there is no need to sequestrate something. No? It goes directly to the atmosphere. Yeah.
Yeah, definitely want to think about, maybe we could call it something like a low-hanging fruit for existing plants in the industry. Ermanno, thank you so much. It's been an absolute pleasure speaking with you today. I just want to take a second to thank you everybody for watching here at World Hydrogen Week in Copenhagen.